welcome back to Alloy Geek. In this video, we're going to take a look at 10 different nickel alloys and sort them with Handheld XRF. In this case, I'm going to use today the Vanta Core by Olympus. This is the brand new Handheld XRF from Olympus. I think it works very well. It has a smart sort capability that you're going to see in this video. And without further ado, let's start testing and talking through these alloys. The first alloy we're going to try is a nickel 200. This is a pure nickel, so we want to see pure nickel show up on the XRF. We'll notice that only the heavy beam was initialized, and now it looks like it's doing a little bit further digging here with a light element beam, but it really doesn't need to. The whole time we're able to get Inconel 200, sometimes called N200, which is just basically a pure nickel grade. We're at 98, almost 99% nickel. Very cool. You'll see that in a lot of applications where they want the properties of nickel. So the next alloy up here, we're going to basically turn the analyzer on again, and we're getting a Hastelloy G-3. We only needed the heavy beam to match that. You're able to see, yes, we were able to grade identify. This is another, all of these nickel alloys are generally, besides the pure nickel one, very high alloy, which is in turn, we end up with things like a very low iron content. 19% iron is actually really high for these alloys. We're seeing nickel at 47%, chrome at 20%. So these are very high alloy grades. Now, you may see some of these around your shop. Now this is going to be a 20 CB3, also called Carpenter 20. And you'll see that the Vanta's UI also gives you a great information as far as sometimes the other name when it's called multiple things in the industry. And here we're going to see another alloy that's similar to that family, but all these alloys, you're not able to tell them apart unless you have a Handheld XRF, so you definitely need one. You know, in just a second, this is Hastelloy 276, also called C-276, and you can see we're able to grade identify really quick. But again, the chemistry is varying a lot here. Iron here is only 6%, but we have almost 16% molybdenum and almost 60% nickel. That's a very high alloy content for any alloy out there. This is a very popular alloy to be used in heat-resistant applications called Inconel 600, and you're going to see that in just like a second we're able to grade identify. And then the analyzer says, wait, there's some other alloys in that family, and I'm going to check for light elements, and that's what it's doing right now. So after it took an additional measurement, it's going to stick with its initial gut of Inconel 600, which is actually the right alloy for this for the grade identification, so that's good. And now we have an alloy called L605. So L605, this is Haynes 25, also called L605, and you can see we didn't even need the light element beam, but what you'll see is this is actually a cobalt-based material with a lot of tungsten. 15% tungsten is a lot. It's hard to actually get in the melt. You know, and we're looking at a cobalt base of almost 49% cobalt with a bunch of other alloy content like chrome, tungsten, and nickel. So very easy to grade identify that with heavy elements, but definitely high temperature resistant or heat resistant when you get up to those high alloy contents, especially having a lot of tungsten. So Inconel 718, this is one of my favorite nickel alloys. It's got a very nice spectrum of alloy content to it. We're a nickel base at 53.5% nickel, and we've got about 19% iron, but you can see all the different alloy content in this. Chrome at 18%, niobium at 5.1%, molybdenum at almost 3%, titanium even is in here. So you're able to see that there is quite a bit of alloy content in 718, which is one of the reasons I like it so much. It takes advantage of, it's kind of some advanced metallurgy, but a lot of these alloys do. So next up here, we're going to run another alloy, and we're able to get Inconel 800 with no issue very quickly. Inconel 800, this alloy here is actually an iron base. It's actually an Incoloy. It's not an Inconel, it's an Incoloy, but we'll forgive Evidence Scientific for mislabeling it there. It's also used a lot in weld wire when you're welding stainless steel pieces together, depending on the alloy. Incoloy can be used for that. This is a famous alloy right here. So I'm going to shoot this one. Let's see if our X-rays are on. And here we go, Rene 41. So the Rene family of alloys, this is just a standard name. This is not the alloy name on the printed here, but Rene got famous in the Apollo space program for the original material for the space tiles that helped the heat resistance of that spacecraft upon re-entry. So that's where the Rene family got very popular, and then that heat resistance that it demonstrated with the astronauts, we were able to deploy that to things like jet engines and high temperature applications. So very cool alloy, pretty famous. And then last up here we've got Waspaloy, and as you can see, these alloys, they all look the same. So if you don't have a label on them, you don't know what's what, and that's why it's really important to use Handheld XRF. So here we go. I've got Waspaloy, right? And Utimet 500 is actually a different alloy. That's not the right alloy. If I click over here, this little drop-down menu, I can select Waspaloy. It's actually a grade match as well. And so you'll see the chemical composition displayed within Waspaloy here. We likely needed to run a light element beam based on the notes here that the Vanta is telling us. But it's also the smart grade match just kind of stopped there and said it matches both of these alloys, which is just fine for our application. So there you go. Now you're able to see that you can sort nickel alloys with a Handheld XRF, and the Vanta Core is a great Handheld XRF to do this. So thanks for tuning in, and we'll see you guys next time.